What if a battery could last forever? Not 10 years, not 20 years, but decades, outliving the device, the vehicle, even the company that built it. In late announcements and quiet technical briefings, Donut Lab made a claim so bold that it instantly divided the global energy community. A solid-state battery capable of 100,000 charge cycles. To put that number into perspective, your smartphone battery survives about 500 cycles in a heavy battery. Around 1,500 to 3,000 cycles. Even the most advanced lithium iron phosphate packs struggle past 6,000 cycles, and Donut Lab says 100,000. That's not an improvement. That's a paradigm shift. But is it real? Or is this another case of lab-grade performance being mistaken for a real-world revolution? Tonight, we go beyond the headlines. We analyze the science behind the claim, the testing methods Donut Lab uses, what they didn't say publicly, and whether 100,000 cycles could actually work outside the lab. This is not hype. This is not hate. This is the truth. Who is Donut Lab, really? Before judging the claim, we need to understand the company. Donut Lab is not a flashy Silicon Valley startup chasing headlines. They don't flood social media with prototypes or concept videos. Instead, they operate quietly, almost suspiciously quietly. Founded by a group of electrochemical engineers and materials scientists, Donut Lab originally focused on industrial energy storage, not consumer electronics. Their early research centered on extreme-duty grid batteries, high-temperature energy systems, long-life storage for mining, satellites, and defense applications. This matters because their priorities were never fast-charging, lightweight packs, or smartphone form factors. They were chasing something else: longevity at all costs. What does 100,000 cycles actually mean? Here's where most people get misled. A charge cycle is not simply plug in once. One full cycle means charging from 0% to 100% or any equivalent combination that totals 100% energy through. If a battery lasts 1,000 cycles, gives daily charging equals approximately 3 years. 10,000 cycles gives approximately 27 years. 100,000 cycles gives over 270 years yet. That's longer than modern electrical infrastructure itself. So, when Donut Lab says 100,000 cycles, the correct reaction isn't excitement, it's skepticism. The solid-state advantage and its limits. To understand how Donut Lab even attempts this, we need to talk solid-state batteries. Traditional lithium-ion batteries use liquid electrolytes, graphite anodes, nickel or cobalt cathodes. These components degrade because liquid electrolytes form unstable interfaces, dendrites grow, and pierce separators. Chemical side reactions slowly poison the cell. Solid-state batteries replaced liquid electrolyte gives solid ceramic or polymer electrolyte. This alone offers higher thermal stability, lower fire risk, reduced dendrite formation. But here's the truth: most companies won't say solid-state alone does not guarantee long life. With fact, many solid-state batteries fail earlier due to mechanical stress, cracking, and solid electrolytes interface resistance buildup. So, how is Donut Lab different? The Donut Lab design, PHLOSOPHY. Donut Lab does not chase high energy density, ultra-thin form factors, or record-breaking fast charging. Instead, they made a radical decision. They deliberately sacrifice energy density. Their cells are thicker, heavier, lower WH per kilogram than EV batteries. Why? Because mechanical stress kills batteries. By reducing expansion, compression, interface strain, a dramatically slow degradation. This is the first key insight behind their claim. The electrochemistry CSRT according to available technical disclosures and patents. Donut Lab uses non-lithium metal anode, a high-stability ceramic electrolyte, a cathode chemistry optimized for structural stability, not energy density. This avoids lithium plating, dendritic penetration, violent phase changes during cycling. Instead of pushing ions aggressively, the system operates in what engineers call a low-stress electrochemical window. In simple terms, slower ion movement, lower voltage swing, reduced chemical aggression. This is boring engineering. And boring engineering lasts forever. How do they test 100,000 cycles? Here's where controversy explodes. Donut Lab did not test full depth of discharge cycles, high current fast charging, real-world FUD cycles. Instead, their test conditions reportedly involved partial charge cycling, narrow voltage ranges, constant temperature, extremely low Saratsky heats. Critics immediately shouted, that doesn't count. But here's the uncomfortable truth. Industrial batteries are often tested exactly this way. Grid batteries don't. Rapid charge, deep discharge, or face unpredictable loads. They cycle gently every day for decades. So the question becomes, is Donut Lab lying? Or are people misunderstanding the application? What Donut Lab didn't POMIC, this is crucial. Donut Lab never said, this battery is for smartphones, this battery is for EVs, this battery will replace Tesla packs. In the media assumed. In reality, their target markets appear to be Grid stabilization, backup power, industrial automation, remote infrastructure, military and aerospace in these use cases. Weight doesn't matter, size doesn't matter, charging speed doesn't matter, lifespan matters. The economics of a 100,000 SEK a battery that lasts 50 years as an asset if Donut Labs technology scales. Grid operators could install storage once per century. Maintenance costs collapse, recycling demand plummets. This threatens lithium mining revenue, battery replacement, markets planned obsolescence, which explains why resistance is fierce. The biggest technical RS-Gaven supporters agree on one thing: scaling is the real challenge. Lab-scale cells are perfectly controlled, free from manufacturing defects. Use expansive materials. Mass production introduces microcracks, impurities, interface inconsistencies. One tiny defect repeated across millions of cells can destroy longevity. This is where most miracle batteries die. Comparison with other CLIMs. Let's compare. Component claims: Cycles Toyota 5,000 QuantumScape -1,000-2,000 KATL000 Samsung ST6000 Donut Lab 100,000. Notice something. Donut Lab is not competing in the same category. They're not building EV batteries, they're building infrastructure batteries. Is the claim physically possible? Short answer, yes. Long answer, only under strict conditions. Physics does not forbid extremely long cycle life if stress, voltage and temperature are controlled. What physics does forbid is 100,000 cycles. With fast charging, high energy density and consumer abuse. Donut Lab never claimed that. The media problem. Here's the real issue. Headlines scream 100,000 cycle battery will change everything. But Donut Lab said, in controlled industrial applications. The disconnect creates backlash. This is not fraud. This is miscommunication amplified by hype culture. What happens if they're right? If Donut Lab succeeds, grid storage becomes permanent infrastructure. Energy systems shift from replacement to installation. Battery waste drops dramatically. Renewable energy becomes more reliable. Disrupt smartphones. It would disrupt civilization. Scale energy planning. Final verdict. So is Donut Lab lying? No. Are they exaggerating? Also no. Are people misunderstanding? Absolutely. The truth is simple. Donut Lab didn't invent an immortal battery for your phone. They engineered an ultra-sludging energy system for the grid. And that might be even more revolutionary. The real the real question isn't, is 100,000 cycles possible? The real question is, are we ready for technology that doesn't need replacing? Because once batteries stop dying, entire industries will have to reinvent themselves.